Welcome to the first ever virtual Kafka Summit. My name is Tim Berglund. I'm chair of the Kafka Summit Program Committee, and I'm also the director of developer advocacy at Confluent. I host a podcast about Kafka. You may recognize me from videos online that are about Kafka, or maybe a conference talk, or something like that. In any case, I am delighted that you're joining us here online. I'm a little bummed that we're not in Austin, Texas as we had planned, but as you know, in the pandemic, these things are happening online. We're all having to shuffle our plans around a little bit. But I'm just delighted that there are so many people that are joining us. There are over 20,000 people registered for this event from the Kafka community around the planet, over 100 countries. And that kind of representation from just people in the world who want to know more about Kafka, that doesn't happen at in-person events. It happens at virtual ones. And so I'm really delighted. Now, you're going to see a lot of great content. You're going to see some great keynotes and wonderful sessions. And that doesn't happen by itself. First of all, it takes speakers. It takes speakers who spend hours and hours and hours building presentations, practicing them, and a whole career of developing the kind of expertise that it takes for them to be able to deliver this sort of content. So thank you to all of those speakers. Also to the program committee. Without these folks, there would be no Kafka Summit. Each one of these people has worked incredibly hard. I can't tell you how proud I am of this year's program committee. They have voted on every single session. They have evaluated hundreds of proposals to narrow them down to the ones that you see in the program today. It's not easy work, and it's often, I'll be honest, the sort of work that happens at night and on weekends and a little bit outside of your normal workday, and these folks have just done so much. So thank you to the program committee. If you should happen to follow any of them on Twitter, say thanks to them online, because they really have made this whole thing possible. And we are virtual this year, but we're hoping to be back to in-person next year. And we're working on dates for a European and a North America summit, and those will be announced soon. I want to give you some quick session highlights, the stuff that's exciting to me. Now, you definitely need to go through the program and find out what's exciting to you. And of course, all of this stuff is going to be available afterwards. So even if you don't watch it during the live session while the speaker is available for Q&A, you'll be able to watch the video later. But I just want to point some stuff out. We've got one called Flattening the Curve by Rishi Tarar of Northrop Grumman. That's about a Kafka use case that has to do with fighting COVID-19. Very timely, should be pretty cool. There is Anna Povsner's Sharing is Caring toward creating self-tuning multi-tenant Kafka. Anna's talk for the second summit in a row was the highest rated by the program committees. It's probably going to be good. Dave Klein brings us Welcome to Kafka. We're glad you're here. Now, when I have looked at the registration data for this online Kafka Summit, so many of you are new to Kafka. And this is like the first event that you've been to, and you're just in the mode of trying to learn things. Dave is a friend of mine. He's a great communicator, and this is guaranteed to be an introduction that makes you feel welcome to the community. So if you're new and you want somebody to help bring you online and who's going to really support you in that process, go to Dave's session. Simon Aubrey brings us Running KSQL DB in the Wild. Simon, also tremendous guy, really has been a KSQL DB user from the early days, back when we just called it KSQL, and he's blogged about it, done some really, really neat projects with Raspberry Pis and all this kind of stuff. He knows what he's talking about. So definitely you want to go see his. That's a key technology that I think is very interesting to know about. We've got Grace Jensen and Kate Stanley of IBM bringing us Reacting to an Event-Driven World. Now, this is a kind of talk that's really exciting to me because it's about the kinds of architectures that ought to arise from Kafka. And this is this neat thing, like once an organization has committed to do something with Kafka, that tends to shape the way you build systems thereafter. Kafka has this viral effect on your thinking about architecture. And Grace and Kate are going to be talking about reactive systems, which is one of those topics to explore in this whole domain of architectures that are implied by the presence of a global distributed commit log. Definitely encourage you to check them out. Also, they're great speakers. They're Summit alumna, and you should not miss them. Now, this is an online conference, but that doesn't mean that we don't have a code of conduct. We absolutely do. I really insist that this be an inclusive, professional, technical conference that is a supportive place for people to be, where people can learn and grow in a safe way. And that means there will be no harassment of any kind tolerated. Be kind, be respectful, help each other. And hey, if you need help, something beyond what you're getting, ask at the help desk within the Summit platform. And if someone you think has violated the code of conduct, whether you've been the victim of that or you've seen it happen to someone else, again, get in the help desk and report that, and we will deal with it, because we really want this to be a place where you can be safe to learn. That's just what we want it to be. And just because we're virtual doesn't mean I don't expect to see tweets, folks. I very much do. So remember your Kafka Summit hashtag, and remember your streaming selfie hashtag. Now, we've established a tradition of posting selfies with your friends and colleagues while you're at Kafka Summit. Now, what you can do is a couple things. So there's a photo booth inside the Summit platform. You can find that on the Interact tab. There should be a link called Get Social. And within there, there's a little photo booth thing that'll just use your webcam and do background replacement and all that kind of stuff that you can choose for the selfie. You can like put Kafka Summit branding behind you, which is super cool. Or you can just take a picture of you at your computer being at Kafka Summit and tweet that with hashtag streaming selfie. I will be looking for those, and I would love to be interacting with you on Twitter around your selfies. And you know, conferences like this don't happen without sponsors, and we are so happy for ours. These are they. You see these logos on the screen, and you're able to visit them in the Explore area of the platform. A lot of them will be hosting their own office hour sessions, doing demos. There are sponsored sessions that some of these folks will be delivering about their products and services. So take a look at those listings. This is not just some crass commercialism and something we have to do because things cost money, but these actually make sense. A lot of these companies are here because you are the kind of people who might need what they do. And if you're trying to build something that they can make easier, then you definitely want to talk to them. So this is not merely a pragmatic accommodation of the fact that things cost money, but there's potentially valuable trading to do with these folks. So check them out. All right. From here, we have our first keynote, and that is my friend and colleague and outstanding communicator, Gwen Shapira. Now, Gwen's not only a great speaker, but she is a deeply talented engineer and engineering leader who has a lot of experience in Kafka. She's been in this community, and she's frankly been in the code for a long time, really a foot in both worlds as a promoter of Kafka, an explainer of Kafka, and a developer of Kafka. So she's going to talk about where Kafka is going. This is really important because she's been with the project for a long time. She's one of the best recognized experts in the community. I think, her history with the project gives her a lot of insight. So you really ought to listen to her. She says, I think, a lot of important things here. And I'm very happy to turn the stage over to Gwen Shapira.
Hi everyone, good morning. It's great to virtually see all of you here. I wish we could be together in person. My name is Gwen Shapira. I am a Kafka committer and a PMC member. I wrote Kafka the Definitive Guide, and I am an engineering manager at Confluent. And on the morning opening of Kafka Summit, I want to join you in reflecting a bit. I want to reflect together on how the world is changing, how things are evolving, how Kafka is evolving with the world. I want to think about things that don't change. Architecture, great software engineering, timeless ideas that we will always use when we build our products. And I want to look at some of the really big changes that are happening in the Kafka community right now, and the possibilities that these changes are opening for us for the future. So let's get started. And I want to start by reflecting a bit about how the world changed in the last, let's say, 10 years. And it's been a lot, so bear with me. The first thing is hardware. 10 years ago, SSDs were new, not very common, super expensive, and also a bit scary. Very few people knew. There were a lot of rumors, a lot of mythology around it. It wasn't the obvious, reliable hardware that we kind of take for granted today. Firstly, the cloud. 10 years ago, the cloud was a very different thing, very new, very exciting, full of possibilities, not part of our day-to-day life, not something that every one of us has to take into account when they're designing their architectures. Raft. 10 years ago, if you wanted to build a distributed system, there were no easy to implement consensus algorithms out there. There was Paxos, and Paxos was quite difficult and, again, scary. These days, we have Raft, invented in 2014. Java got a lot better, a lot easier to use, a lot less garbage collection headaches, a lot easier to get good performance out of. And of course, Kafka use cases changed a lot. If you think about it, 10 years ago, microservices were really not a thing. Today, it is the thing. So obviously, with all those changes in the world, Kafka had to evolve and change with it. So if we look all the way back to original Kafka, you may remember, maybe you even used it. It used to be a single machine system. We had no replication protocol. And it was just a simple log. So then we added replication, which opened up this entire world of distributed systems and of scale. And then we added low compaction, which added all those key value store dependent use cases. And then we added Kafka streams, and we added exactly once, and we added Kafka Connect, and there was this entire ecosystem of microservices and stream processing that really grew around Kafka. So if you think about each one of those changes, it's not like a small thing. It was big in terms of what happened to the Kafka architecture. And even more, it was big in terms of what it did to the way we develop applications and develop software. It turned Kafka from this really glorified pipe, getting data at high scale from here to there, to a very versatile system today driving gazillion use cases and all sorts of applications. And every one of those changes opened up something new that we could not do before. So it's worthwhile paying attention to those big architectural changes and think about what can we do with them. And obviously, Kafka's architecture evolved a lot, but it wasn't done in a random, haphazard way. It wasn't done in a hacky way. It was done while maintaining a lot of the core architectural ideas and integrity. And this is important because architectural integrity doesn't happen by accident. You have those key principles that you really try to keep in mind while designing your software, while working on the project. And conceptual integrity means that you can look at every part of the system and really understand the whole, which makes it easier to develop the system, which makes it easy to learn the system, which makes it easier to operate the system. So preserving this architectural integrity is really key for what we in the Kafka community do and care about. So let's look at some of the architectural choices we made in Kafka and why we believe Kafka has this really important property of architectural integrity. And when we think about Kafka, and I spent a lot of time thinking about Kafka, what I'm really thinking about is this big idea. How do I explain to someone what Kafka is all about? And in my mind, it's the abstraction at the core of Kafka. I'm talking, of course, about the log abstraction. And this is important because once you pick the correct abstraction to describe your world, if you do it right, you open up inherent efficiencies of the systems that you're building on. So instead of working against the stream and just fighting this big uphill battle, you are enabling yourself to build something that is incredibly efficient. You can easily fill CPU caches, use prefetches, have best use of disk, best use of CPU, low-level kernel operations. Everything is suddenly working in your favor. And we really believe that our log abstraction opens up all those things for Kafka. So we have this core abstraction, and we believe that it allows us to build a high-performance system. And here's how it works. Here's how you build a high-performance system in a nutshell. You start by really understanding your hardware, all the foundations, hardware, operating system, the Java virtual machine as a platform that you build on. And you need to understand what is it actually capable of. In the best case scenario, if you do absolutely everything right, what is the bar? What is the throughput? What is the latency that you can really get out of all the components that you have in the physical world? This is the starting point, and it's up to you to obviously meet the bar and not detract from it. And once you have all that, you learn, as I explained, how to work with the system, how to do the right design, use non-blocking I/O, use prefetches, use memory locality, page cache optimizations, have a great optimized wire protocol. You make all the choices in order to make the most out of the hardware and operating systems that you have. And after you did everything right on the design as well, there's still one very important thing that you have to do, which is run a system with a profiler, with a benchmark, and understand whether you fell short of your goal. Because it is so easy accidentally. You can spend months, weeks trying to create the most amazing theoretical system, and then you will have one really silly line of debug logging that does not have the correct condition and does a bit too much work, and you just threw it all away. So in order to get great performance, you have to be knowledgeable, you have to make smart design choices, and you have to be a bit obsessive about making sure you don't throw it all away and just keep testing and iterating over and over again, which is what the Kafka community became really, really good at. So with this solid foundation, let's look at some of Kafka's architectural principles and goals and how they were implemented until now, and then we'll talk a bit about how they evolved. So the first goal, and this was always true for Kafka, we always, from day one, wanted to have one huge Kafka cluster per company, with the goal of having a shared source of truth that everyone can integrate with and really help you avoid silos. The whole idea that every part of the organization is kind of off into la la land with their own view of the world is not a very good one. So we built Kafka with this goal in mind. You're going to throw different workloads on it. It's going to perform great. And if you need more capacity, you will add more brokers and you will get more capacity. And the idea is that the fact that you throw different workloads at it will not contradict each other. You can actually see today, if you think about it, the internet has gazillion how to scale Kafka guides, but you don't really have a lot of how to scale Kafka for this use case versus how to scale Kafka for the other use case. The main thing is that it doesn't matter if you do lots of reads, lots of writes, somewhere in between. Kafka, pretty much out of the box, will work fairly well with that. And a well-tuned Kafka is well-tuned for the hardware and operating system, not so much for your workload. So, because Kafka was written for day one to support diverse workloads. And the goal was that as we add more and more brokers to get more and more capacity, we want it to grow linearly. We want broker number 3 that you add to add as much capacity as broker number 153. It just have to go up and to the right all the way. So we may have some design choices that currently limit us from achieving this goal, but we never abandon this goal. And we are working on obliterating all those obstacles. The second goal we had in mind was being very operationally friendly. Basically, you download Kafka, you unzip it, and it should just work. And this is really what attracted me to Kafka from day one when I started contributing to the project. I was actually evaluating for a customer a lot of different projects. There were gazillion Kafka lookalikes at the time. I don't know if you guys remember. There were Scribes, there were Flume, there were all those things. So I did a bunch of evaluations. And one of the things that caused me to work on Kafka is that out of all of them, this was literally the easiest to use, and it had the best documentation guiding you on how to start. So that was great, but obviously just the first 5 minutes is not the entire operational experience. Being very observable is super important. How do you know if things are working well, if you need to do something different? Having all those metrics that we keep adding to, having very detailed logs and the request log to allow you to dive one layer deeper, being very easy to automate, interacting well in all those cloud environments. And maybe most important today is our obsession with performance, means that Kafka is very efficient, which means that you can actually run huge scale and amazing throughput on tiny, cheap machines. The tiniest and cheapest machines that you can find in the cloud will already give you incredibly high performance. And this does not happen by accident. It happens because you have people who are obsessed about these kinds of problems. And it is super important. Obviously, these days and day and age, everyone is trying to slash pennies and dollars out of their budget. Running something that is cost effective is super important. And last but not least is the idea of elasticity. I already mentioned that Kafka should be able to scale as you add brokers. We want it to be easy to add brokers. And we want it to automatically adapt to new workloads. And we talked about why is it important, but something I want to point out is why having it dynamic is so key, because you don't want to spend all your time manually tuning things for this workload and that workload. We are living in a world that is becoming increasingly serverless. And if you look at how things run in the cloud, it used to be like when I ran things in the data center, it used to be that we basically ordered machines maybe once a quarter, maybe once every 6 months. So if you order machines every 6 months and then it takes you 3 more days to move data around and make use of the new machines, nobody will care. Obviously, we're now living in a world where we need to be way more elastic than even that. And in a second, I'm going to tell you how we're getting there. So we have all those design considerations, right? The scale, our big concepts around efficiency, being operationally friendly. Let's see about how those played out in the two biggest changes that are happening in the Kafka world today. So for those of you who are not following the mailing list, there are two really, really massive KIPs, Kafka improvement proposals, going on in the Kafka community, being discussed, being developed, being reviewed. One of them is Kafka tiered storage, and the other is the replacement of Zookeeper with a metadata quorum. And I'm going to talk about them at a high level right now, like this is a keynote. I'm not going to talk about every single detail, but it's a Kafka community, it's a KIP. You can read everything in the wiki, you can read all the mailing list discussions. There are so many fascinating questions that are being discussed, really amazing distributed systems, nitty-gritty. How do we send notifications? How do we know that everyone read it? What do we do if someone is getting split off? And most important, the conversation is still going on. Everyone here, or virtual here, can participate. So let's start with tiered storage. This is the idea that recent data is much more valuable than old data. It's going to be read much more frequency, and the latency of reading it has to be much, much lower. So you want to read it faster, and it's way more important. You're willing to pay more in order to get those properties. All data, on the other hand, maybe you cannot legally delete it. Maybe every month there is a data scientist who really needs to read it, but most of the time, nobody cares. And even when the data scientist has to read historical data once a month, he may need high throughput because he needs to read all of it, but he doesn't care if it's 5 millisecond latency or 600 millisecond latency. He will need to read petabytes of data, and it will take him a few hours no matter what you do. So throughput is really important. It's obviously very important not to pollute Kafka's caches while you do it, so not to harm those real-time workloads. But other than that, you can put it on cheap storage elsewhere and completely forget about it, which is a fantastic idea. We should have done it ages ago. We want to thank the team from Uber, Harsha, Satish, Ying, if there's anyone else from Uber or somewhere else who was working on it. I'm sorry, those are the names I've seen the most come up on the mailing list. They've been doing an amazing job driving it with the community. And while it sounds like a great idea to have different storage come with different tiers, the really big thing, the really amazing addition to Kafka is that it opens up elasticity. So as I mentioned earlier, you take all data and you move it to cold storage. Imagine S3, imagine HDFS, and you keep only the most recent data, maybe a few megabytes, where Kafka is. It can even all fit into memory. You get amazing performance if it all fits into memory, but otherwise you have SSDs. And because the data in Kafka itself is very small, it means that when you add a new broker in order to scale, you only copy bits of data, few megabytes. You don't have to copy the entire partitions that nobody will ever read, right? That's amazing. Instead of spending hours, maybe days, copying data that will almost never be read to the new broker just so you can start using it for your real-time traffic, you move only the minimal data needed in order to start serving your real-time traffic. It takes maybe a few minutes, and that's it. Your broker is online serving your real-time traffic. Very elastic. You can do it a few times an hour if you have this kind of workload, few times a day if you have that kind of workload. Move things around, add brokers, remove brokers. It's a whole new Kafka. You can tie it into auto-scaling groups. Totally different world to live in. And if that wasn't enough, there are even more benefits to it. This is my, but wait, there is more slide. And the big deal is that if you now moved most of your data to very cheap storage, it means you can skip lots and lots and lots of it. And maybe certain years for tax authorities, maybe never delete because it's a bit risky and why even bother. And it's on a totally different type of storage. Theoretically, you can use something that is not Kafka to process it. And this is key because while we're implementing Kafka, or the nice guys from Uber, Harsha, Satish, and Yung, implementing this storage for HDFS or S3, they're building it in a way that is pluggable, which is the most important part of this architecture choice. Because if it's pluggable, it means you can use something else. It means that if you want to try Elastic, MySQL, Twitter, for that matter, you can actually experiment what kind of storage would be the best place to tier old Kafka data. So it can get quite exciting. I'm looking forward for a lot of innovation in that regard. And maybe no less important is the idea that it saves us time. Because I don't know if any of you tried to do capacity planning for Kafka. First of all, if you have a lot of it tends to be storage driven. Like if you have very high throughput, all of it is how long can I keep the data and how much storage do I need to buy from it. And if you think about the list of requirements, it's a bit insane, right? It has to be low latency because you don't want to have massive latency when you start using the reading from disk. It has to be high throughput. It has to be large to store all the data, and it has to be cheap. The number of storage systems that answer to all those criteria is approximately 0. So we need to find better ways to do things. And by having to make different decisions for the fast online data versus the old high throughput, high latency data, it reduces a lot of the headache around this decision making. Which brings me to the really important question, which is, which beach am I going to go to now that I don't have to do capacity planning for most of my time, really? Send over recommendations. Okay, the other big feature that I want to talk about is Zookeeper removal, and with it, our new controller. So that's Keep 500. Keep 500 got all the marketing, but there's a bunch of keeps that have all the interesting bits in them. So you kind of have to find Keep 590, Keep 595, Keep 631. So it's kind of like this really big project, multi-part keeps. And at the core of it, the key idea is that we're going to replace Zookeeper with a Kafkaesque version of Raft. So if you think about it, consensus is about agreeing on a shared state. Metadata is about agreeing on a shared state. And both Zookeeper and pretty much every other system do it by writing to a shared log. And surprise, Kafka is very good at writing to a shared log. We already know how to agree on a shared state and distribute this shared state between a lot of members of the system by managing those shared logs. So it always felt a bit silly that some of Kafka state is managed on a log in Zookeeper, while most of Kafka state is managed on a log in Kafka. We've written a log processing system, but the key parts of our state are in someone else's log processing system. The entire Kafka journey started with Jay's realization that log is the big abstraction at the core of every data system. We're just bringing those ideas back into Kafka in a more holistic way. We are making Kafka a lot more Kafka-like. We like logs, so we put more logs in our log processing system. It just makes perfect sense. And obviously, we're not just doing it because it sounds like a very cool architectural idea, although we kind of are doing it because it sounds like a very cool architectural idea. But in order to do it, we had to convince ourselves that there are some practical benefits to this really cool architectural idea. So if you think about how Kafka is communicating state right now, suppose that I had leader election and the controller needs to let everyone know about the new location of the leader. It basically starts opening connections to every one of the brokers and saying, hey, there's a new leader, here are the followers, here's the new ISR, congratulations. And it does it in a way that's blocking. And while we did a lot of work optimizing it, we're kind of reaching the end of this architectural direction. But this is okay, because we already know a much better way than point-to-point communication to communicate state in a large distributed system. We know that the right way to distribute it is by writing to a shared log and have everyone else consume the state from the shared log. It's asynchronous and it scales amazingly well. We know that because we already wrote a system, many of them, that work exactly in that way. So imagine that the current cluster state is being written to a log. Every broker consumes it. You know where the leaders and you know where the followers and you know everything else about Kafka metadata, topic configuration by reading this log. And you create your own copy of the current state in memory, which means that if controller has to fail over, it's instantaneous. The new controller already has the state from memory. It doesn't have to refetch it from Zookeeper, one of our biggest bottlenecks at the moment. Everything that you need to communicate is much faster and much less blocking this way. A lot of things are almost instantaneous, which allows us to scale our partition count in ways that were not previously very easy to imagine without those gigantic machines. So we are fairly confident that we can use this architecture to scale into the tens of millions of partitions on a Kafka cluster. Now, the other benefit of doing this new architecture is that we do, in fact, get rid of Zookeeper. And the main benefit of getting rid of Zookeeper is that you no longer have to manage Zookeeper. I know everyone tells me, oh, Zookeeper is super stable, it's super easy to manage, blah, 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 yeah, okay. But it's still, you have to learn two systems. You have to learn Zookeeper, you have to learn Kafka. You have to learn how to monitor, how to secure, all those best practices, and you have to learn it twice. This is a lot of work. I already told you how much I love doing capacity planning. Imagine having to do it twice. Well, you don't have to imagine. You're already doing it twice. And to make things worse, Zookeeper and Kafka are conceptually very different. I remember in the first Kafka Summit, that was, I believe, 5 years back, someone stood on stage and he told us this really funny talk, 101 mistakes I've made with Kafka. And one of them was to set up 8-node Zookeeper. Now, it's not a Kafka mistake. 8-node Kafka cluster with 8 brokers is just fine. It is a Zookeeper mistake. And because how would you know that 8 brokers are okay with Kafka, not okay for Zookeeper? So obviously, no Zookeeper is a good operational improvement. But even more than that, remember I explained about every leader election and every change getting written to this shared log? You now have an immutable log with every leader election and every change that happened to your distributed system. If someone asks you, what was this performance blip yesterday and how was it different from a performance blip 3 weeks ago, you have this log to go to and inspect. And this is the sort of truth. It's not that, oh, Kafka did one thing in memory and maybe it logged stuff correctly, maybe not. This is the truth. So it's going to be really fantastic. And the key point, the key thing to remember here, obviously, each one of those keeps is cool in its own right. Taken together, this is a state shift. This is a step jump in Kafka architecture, just like adding replication was, I don't know how many years ago. It will make Kafka more pluggable, more elastic, more cloud-like. And the key things to remember about this new architecture is the elasticity adding and removing brokers, adjusting to new workloads. This is all now within our reach. Integrated, both are conceptual integrity. The ideas that the same ideas of the log are now being used throughout Kafka everywhere, and integration with external systems like S3 and HDFS, all those different storage systems, and infinite. And by infinite, I mean infinite. Infinite storage, being able to just store as much data as you want without artificial limitations, being able to add as many brokers as you want without artificial limitations, without decreases in performance, and being able to add as many partitions as your use case requires. So those are just two examples of Kafka's core really evolving in an amazing way. And I really have this wish list in my head of all the other ways Kafka could keep evolving. And I'm so tempted to dump this entire wish list on you because it's an exciting wish list. This is the thing that makes me get up every morning and go to work after I've been working on Kafka for 6 years, guys. It's still amazing that we can keep on making it better. But I'm going to not dump this wish list on your head right now. I feel like it may be a bit unfair for me. And part of the reason is that Kafka is going to keep evolving. And the world will keep evolving. And you're the guys who need to make Kafka keep pace in the world and make it adapt to all those changing conditions in reality. And the fact is that Kafka will always be driven by community members saying, oh, I actually need something else because things have changed. And what I really want you to take here as a takeaway, other than people are doing freaking cool stuff with Kafka these days, is the idea that Kafka is an evolving system and that you as a community member own it as much as everyone else. And you can improve it to meet your needs. And it's not just something static that you evaluate, does it or doesn't it meet my needs? It is the thing that you own and can make better, and we want to make it better together. And as long as we keep Kafka's North Stars in mind, our idea of performance from first principles, from the ground up, the ideas of elasticity, operational simplicity, high scale, we think Kafka is the event log streaming system for the future.
It's fairly common for organizations to be doing more and more in the cloud as time goes on. If the cloud isn't a part of your life right now, it probably will be soon. Up next is a virtual fireside chat led by Jun Rao, co-creator of Apache Kafka and co-founder of Confluent. He'll be joined by Chirag Dadia, director of engineering at Nuuly, and Ravi Vankamamidi, director of technology at Expedia Group. So between the two of them, you can travel and you can look good doing it. Chirag and Ravi are going to discuss their experiences with Apache Kafka, the advantages of doing event streaming in a cloud environment, and what that lower friction development experience has meant to the business. Jun, take it away.
Good morning, good afternoon, good evening, everyone. Welcome to Kafka Summit 2020. Today, I have two special guests with me, Chirag from Nuuly and Ravi from Expedia. And we're going to talk about how Apache Kafka and event streaming have impacted their own organization. So welcome, Chirag and Ravi. To get us started, maybe we can start with you introduce yourself a little bit, your organization, and your role there. How about we start with you, Chirag?
Hi, everybody. My name is Chirag Dadia. I'm the Director of Engineering at Nuuly. Nuuly is the latest addition to our family of brands at Urban Outfitters. Nuuly is a clothing subscription rental service. We built Nuuly from the ground up with Kafka as the backbone. Kafka drives our front-end experience, our back-office operations like warehouse management systems, order management systems, real-time inventory, all of our machine learning and data science use cases, and finally, our reporting and analytical solutions.
Sounds good. What about you, Ravi?
Hi, I'm Ravi Vankamamidi. I'm Director of Technology at Expedia Group. Expedia is a world travel leader carrying such trusted brand names as Expedia.com, Hotels.com, and Vrbo. Within Expedia, I'm responsible for building intelligent, context-aware conversational platform that can converse in natural language and can seamlessly switch between virtual and live agents.
That sounds like an interesting use case. We can talk about that a bit later. Next question. What about your guys' past experience with Apache Kafka? And why did you guys choose Kafka as a technology? Again, let's start with Chirag.
Kafka at Nuuly was not my first exposure to the technology. As a technology consultant, I've had the opportunity to work with clients in fintech, healthcare management, and entertainment industries. In my opinion, most of these clients had a need for real-time processing of their transactional workflow and a view into their real-time data. At Nuuly, as we were building the platform from the ground up, we had a need to make sure that our inventory position was consistent and accurate. Using Kafka's distributed nature, exactly when semantics and transactional support, along with the persistent store, we were able to solve some of those problems. Nuuly is also a cloud native application and a platform. As a result, security, scalability, consistency, performance, and monitoring were very important aspects of the platform. Kafka's ecosystem is quite vast, and it allows you to solve some of these problems, especially if the platform is hosted on Confluent Cloud. Scalability becomes almost a non-concern. It's very easy to scale the platform and to increase the capacity of your clusters and be able to handle large volumes as the business demands. So those were some of the challenges and problems that we were able to solve as a result of using Kafka and Kafka's ecosystem.
Yeah. Ravi, what about you?
This is the first time use of Kafka at scale for me. Previous to this, I used other messaging technologies, but Kafka is the first time for me. When we are building this conversational platform, we needed to bring together some really complex technologies like fulfillment services, NLU, NER services, as well as real-time analytics. We chose event-driven architecture as the core of our platform, for which we needed a messaging service that gave us order guarantees, exactly when semantics, and replay semantics. Not to mention that it had to be extremely scalable, highly available, and was simple to use. Kafka hit all of these points for us.
Great. So both of you mentioned being more real time, being more scalable, being more persistent. Yeah, I think those are all good features of Apache Kafka. Next question. That's just for Chirag. At Nuuly, you guys, of course, are building this event streaming platform around Apache Kafka. Could you share with us some of the technical challenges you were able to solve with this technology?
Yeah, absolutely. A rental subscription business is a very different model compared to an e-commerce platform. In an e-commerce platform, you typically have one-off transactions, whereas in a subscription business, you have items that you're sending out to your customers, and then at the end of that cycle, they return it back to you. And then you may have to make those items be available for your next set of customers. At a very basic level, in an e-commerce platform, you track inventory at a SKU level and the number of units. But in a subscription business, you really have to track individual units. And you have to understand the life cycle of these units. You have to understand how long does the garment is going to last. How many wears are you going to get out of that garments? So really, what we wanted to do was really track the full life cycle of these garments, understand how we're going to solve these problems. And as a result, we ended up building our own warehouse management system, our own order management system from the ground up. And then real-time inventory and accuracy was extremely important. Our customers go to our site all the time, looking for things that they want to rent, and knowing that things that are available or being displayed on the site are available and to rent is super critical. Well, what you don't want a customer experience where somebody tries to place an order and then they get a response back saying, sorry, we could not fulfill your order because we did not have enough inventory. So personalized customer experience and really a real-time inventory management was a key factor and some of the technical challenges that we had to solve.
Yeah, that's great. I imagine, with this new technology, the customer experience is going to be a lot better, right?
Absolutely. We personalize all of our customer experience in the sense that no two customers actually see the same catalog, and all of the recommendations that we make on the site are extremely personalized for you.
That's good. Right. Next question, that's for Ravi. At Expedia, you guys mentioned you are building this new intelligent chatbot service. So what was the original chatbot service like, and what are some of the technical challenges you were able to overcome with the new technology based on Kafka?
We had a legacy chatbot service that relied on an in-house messaging platform that was effectively a question and answer bot. And it was very limited in scope to post-booking scenarios, and it could handle a two-party conversation. We needed to have something closer to a travel assistant that could handle context-aware, multi-party, multi-channel conversations. We needed to bring together natural language understanding, translation services, real-time analytics, all of them, and also to make it scalable across multiple brands. To handle this, we're looking for a messaging platform that was highly scalable and provided us with order guarantees, exactly one semantics. And by the way, it was fast and also super scalable. The legacy chatbot did not have all of the requirements I mentioned, and it could definitely not scale. And the accompanying messaging service could not scale to what we were looking for, to bring together all these disparate systems into an event-driven architecture. So for us, Kafka met all of the requirements that we were looking for. Now, within an year after the rollout, we effectively doubled the NPS score.
Yeah, be able to translate to different language in real time. That sounds like a very cool application. Next question, again, is for both of you. You guys are both using this managed service, right, for Apache Kafka in the cloud. So how do you compare that with self-serving? This time, let's start with Ravi.
Kafka is a simple, easy to use service, whereas managing Kafka is not. When we were starting to build out the conversational platform from ground up, we needed to make sure that we could rely on a messaging platform that was scalable and that was easy to use, yet we did not want to spend a lot of time managing it. We wanted to make sure that all of our developers are focused on building out the core conversational platform components and not be distracted with managing the Kafka infrastructure. So for us, going to managed Kafka easily helped us shave off close to about 6 months of calendar time, because it would have meant that we needed to have recruited 2-3 experts in Kafka, then trained them on our platform before they could become fully productive. So I think managed Kafka truly helped us speed up our time to delivery.
Great. Chirag, what about you?
Yeah, so Jun, we had a very unique challenge. We had a timeline of a year from inception to launch. So we were taking on this extremely difficult challenge of building our own warehouse management system, order management system, and some other components. What we really wanted to do was focus on building those core business capabilities. and really not build any core competency in trying to manage Kafka. Kafka is a pretty powerful system, but does require some deep knowledge in order to manage it and maintain it. So one of the benefits of us migrating or using Confluent Cloud was that we were able to offload a lot of those responsibilities to the experts. Confluent, all of the engineers at Confluent Cloud obviously know Kafka in and out. And so they were able to really engage with us early on, help us validate our architecture, help us tune our applications, provide us guidance in terms of how we could achieve the scale that we wanted to achieve as the business grew, while taking on the responsibility of managing the full Kafka cluster, which really helped us, just kind of focus on some of the business problems. I would also echo what Ravi said. Hiring Kafka engineers takes a long time. It's a specialized skill. And with the timeline of a year, if we were to go down the path of hiring Kafka experts on our team, we would have easily delayed our launch by six months to a year, which is significant. So really being on Confluent Cloud helped us sort of get over that hurdle and get started real quickly, because it's really easy to go provision a cluster in Confluent Cloud. So we were able to just start building applications right from the get-go.
So ease of management, time to market, those are like a great benefits of using cloud service. And the next question, it's for you, Chirag. At Nuuly, you guys have Kafka at the core of the system, but it sounds like it's also interacting with a lot of other systems. So what other systems are you interacting with Kafka, and how do you guys manage those?
Yeah, absolutely. So before we started down the Kafka journey and actually using Confluent Cloud as a managed service, we actually had a lot of custom pipelines, one-off pipelines that we had built. We have to interact with a ton of enterprise systems as part of this offering. We have vendor management systems at a URBN level. We have revenue management and financial systems, analytical and data warehouses. And all of these one-off jobs and one-off ETL pipelines were extremely difficult and cumbersome to manage and maintain, and very fragile. By adopting Kafka as a technology and more specifically also as a managed service, what we were able to do was really leverage Kafka under the covers with Kafka Streams, and more recently Kafka Connect, to really solve these problems and replace some of these pipelines that we had that were extremely fragile. We're also exploring the use of KSQL. At the time, KSQL was not a managed service, but now it is available on Confluent Cloud. So we're exploring use of KSQL to replace some of these custom pipelines.
Yeah, I think that sounds like a good use case for those Connect framework. Okay, next question. That's for Ravi. We all know that COVID-19 had this unexpected impact to a lot of travel companies like Expedia. So could you share with us a little bit, how this pandemic has impacted Expedia, and what are some of the technologies you guys have been using relevant to this unusual event?
COVID-19 hit travel industry in a really big way. The traffic that we got hit overnight was incredible, and nothing could have prepared us for such a tsunami of traveler requests. During normal course, we planned out traffic spikes of up to about 3 to 4 times that our platform was rated to handle. But the amount of traffic that we got hit with was close to 30 times. During this time, Confluent worked with us very closely, supported us very closely. ensuring that we achieve close to zero to no downtime at all, in spite of such a large traffic spike. So we're very happy that we chose Kafka as our messaging platform and Confluent as our vendor. In addition, we also needed to onboard new skills fairly rapidly. Thanks to the event-driven architecture that we chose, we could onboard some critical skills in a very short span of time, like literally within about 4 days, that could support new traveler scenarios in the hour of traveler's greatest need. It was reflected in the customer satisfaction rating, the NPS score, doubling during this period.
Yeah, I think in some sense, this pandemic forces all the business to be more digital, to be more real time, so that they can cope with unusual events like this. So last question for both of you. Any final advice you want to leave with the audience of this conference? A lot of them actually are technical leaders in their own organization.
Yeah, so if you're starting out on an event-driven architecture journey, I would suggest pick a non-mission critical use case or an application. Provision a Confluent Cloud Kafka cluster. Using Kafka Connect technology, import data from your existing sources. Then, using KSQL, try to build an application that derives intelligent business value. What this allows you to do is understand Kafka's ecosystem, and some of the technology nuances. It'll also give you some intuition about how to build an event-driven architecture and a complete platform based on event-driven architecture.
Sounds good. Ravi, what about you?
The beauty of event-driven architecture is that you can start small. Pick a small use case. Use managed Kafka service so that you don't have to worry about managing the Kafka infrastructure from the get-go. Take your use case to production. Taste the success. This is a great way for you to both retire legacy systems or even to onboard new services.
Sounds good. Both of you mentioned, start small, try to get success, one use case before the wide adoption. Okay, with that, thanks a lot for your time, Chirag and Ravi. I wish you continued success with adoption of Kafka and event streaming in your own organization.
Thank you.
Thank you very much.
Next up, Jun is going to talk to Leon Steele of Citigroup. Now, Citi is a huge planetary scale financial services company, so the problems they have to solve are large. But I want you to listen carefully to what Leon says. His problems probably sound like yours. He needs to build real-time dashboards. He needs to improve customer experience. He's got legacy systems that don't all want to be event-driven starting tomorrow. They're still using request response mechanisms and REST APIs, just like normal people. But he sees that putting an event log at the heart of the enterprise is the best way forward to unifying these legacy systems and meeting the business objectives he's on the hook to meet. So, Jun and Leon, take it away.
Good morning, good afternoon, good evening, everyone. Welcome to Kafka Summit. Today, we're going to do an interview with a special guest. Technology is a longtime Kafka user, Leon Steele from Citigroup. Leon, welcome.
Thank you for having me.
So before we talk about Citi, Leon, maybe you can start just by telling us a little bit about yourself and your personal journey of Apache Kafka.
Sure. I started with Kafka and Confluent, actually, about 8 years ago. I was at Credit Suisse at the time, looking after derivatives and risk for North America. And we were looking at data and how to combine data in intelligent ways. And after that, about 3 years ago, I moved over to Citigroup. And I'm using Kafka here, where I look after equity market making.
That's great. Now let's talk about city. Of course, city is like a large organization with hundreds of thousands of people. What's like working at the city? What's the technology stack at city?
As you said, Citi is enormous. It's a large global bank. It's the definition of at scale. There are 97 offices, 73 trading floors, about $4 trillion worth of transactions are processed every day. And as you can imagine, in a large global organization, the technology really runs the gamut from large-scale systems to microservices to Kafka, message buses, REST APIs. We have a full spectrum of technology that we're using across the plant.
That's great. Okay, now let's get down a little bit to Kafka.
Sure.
Over the past years, including Citi, you have worked probably with multiple use cases of Apache Kafka. Now you have to pick one. What do you think is the most interesting use case that has the biggest business impact?
I think when you look at equities trading in a investment bank, you're dealing with data that has different timing. So you have real-time data, stock prices, things that are ticking. You have data that's pretty static, terms and conditions, things like that. And then you have data that's updating periodically, things like position updates. So if you can use a tool like Kafka to pull all that data together and combine it in ways that you display to end users, whether they be traders, salespeople, managers, and you provide them analytics across that data, it's extremely powerful. And so I think the systems we built using that have really transformed the way people think about, really what's possible.
Is there any aha moment from a business impact perspective?
Yeah, I think, we took a report that somebody was receiving the next day, and we were able to show them that updating in real time or near real time, on a website. And I think, and they were able to manipulate the data. And I think when they they understand that you can do this now and the technology is there and it's at scale, I think you see a light bulb go off in their heads and they say, well, what else can you do? Can I get data from here? Can you combine this? Can you show me this? And it really changes the nature of the conversation.
Now, let's talk about just adopting the technology. Citi, of course, is a large enterprise, potentially with lots of legacy systems, right? So how easy it is to adopt a new event streaming technology like a Kafka at Citi? Any resistance in particular that you have encountered?
Yeah, I think that's a good question. At any large organization, including Citi, you have senior technologists who are very thoughtful, smart, and opinionated, frankly. And when you discuss problems and solutions, they bring a wealth of experience to bear, which is obviously positive. But at least the discussions on why you chose the solution you chose, and if they don't have a frame of reference around event streaming architecture, it's a more challenging conversation. You get questions like, why not just use REST APIs, or why not use a message bus for this use case? And I think being able to have those conversations thoughtfully and respectfully is very important in a large organization as Citigroup. I think also Citigroup, I said, is the definition of being at scale. By being that large and having financial regulations and around the globe, being able to manage data, federate data, put in proper security controls. It's not an environment where you can download a piece of software off the internet and just upload it and release it to production. We have very careful and systematic approaches for doing production releases, and that can be challenging.
Yeah, so that sounds like the organizational resistance part. What about technical challenges? Anything that you have encountered that you have to overcome? When
we were putting Kafka in initially, we we have challenges around sizing the environment, and we worked with Confluent on that. Using Zookeeper to right size our footprint, and then there were technical challenges in implementing it. For example, using Kubernetes with a cloud implementation of Kafka was more challenging than it seemed out of the box. And we worked on which versions should we be using, and really it was a lot of back and forth with Confluent to resolve some of those technical challenges. I spoke with some of my colleagues, and they had issues with connectors, where there were security concerns around connectors, and they spoke with Confluent, and we worked together on patches for that to make sure everything could function at the scale and security level we require.
As good as you mentioned the difficulties of managing Zookeeper, the good news, we have this KIP. You may be aware of KIP 500. We're in the process of removing the Zookeeper dependency within Kafka. So hopefully that will make Kafka in general easier to manage in the long term.
I think that approach is the holy grail of elasticity.
Yeah,
so
that's great.
I'm excited for that.
Now, let's talk about Kafka as a technology. So when you picked like Kafka as a message bus, right, within the city, there are, of course, other choices. What made Kafka appealing to you?
I think it's the right tool for the right problem. I think we do have message buses at City where, there are use cases where that's appropriate. We do have REST APIs where that's appropriate. And I think what really worked well for us with Kafka is the ability to do analytics over a persistent amount of time. So it's not just a fire and forget message bus. It's not an intraday system where, we can only look at today's data. We can actually keep a record of data on Kafka over a longer period of time, aggregate information and do analytics across, multiple days. We can set how long we want to do that. And I think that was, really effective at getting people to look at it differently.
Yeah, that's good. Now, if you look at the Kafka itself, right, it's a great technology, but I think for a lot of the companies adopting technology, is not always easy because, you need essentially build a solution out of that. So can you talk about what other things you have to do to make the adoption of a technology like Kafka successful within City?
Yeah, I think we need to, when you approach any organization, City, if you're a new joiner somewhere, or you have to look at the culture, and you can't come in and say, Kafka, here's the solution. Let's go look for problems. You have to look at the problem thoughtfully. And, I like to think of Kafka when I talk to technologists is, we have databases, and everybody's familiar with the database. And at the core of a database is a log. And before it gets stored in a table, before anything happens, it's written to a log. And that log is distributed and has sophisticated ability to distribute that log over multiple sites, multiple instances. It's fault tolerant, things like that. So it's keeping a record of everything that's happening. At the same time, you want to be able to access that log. So if you're at City or another large organization, you want that data recorded, and you want that data accessible across your organization in a controlled way. So if you had that ability and you didn't have to go to a database and get an update and publish that update somewhere, it was just a log that's running, you have something powerful. Now, if you then take that log and add a pub sub model to it, so I could subscribe to updates, I could publish updates, more similar to a traditional messaging bus. If you combine those two things, you have a really, really powerful tool. And I think, when I talk to people about Kafka in the technology space, I like to orient them in that direction initially, so that we could then say, okay, this problem, if it's low latency, fire and forget, intraday data, that's not the right use case for this. But if you're looking at, I want to do analytics across data, I want to combine different sources of data, now you have a very, very powerful tool in your arsenal.
Yes, yeah, and that the central commit log, has to be made really reliable, durable.
Yeah, I think if you think about Citigroup, you have obligations to be present. So it's not, a site where if you're down for a certain amount of time, customers understand. And, you're dealing with financial regulated environments where uptime and resiliency really needs to be industrial strength and really fault tolerant. So getting that log capability in a way that's really been proven at scale over and over again across the industry is key.
Any advice to our audience? A lot of them are technology leaders in their own organization. What can you say to them, adopting this event-driven platform in their organization?
Yeah, I spoke a bit about people bringing a wealth of experience to the table. I was thinking about this, and I taught my son when he was very young string theory. And at the time, I thought it was an experiment. Let's see what happens. Because it was very hard for me to understand string theory. And he immediately understood what I was talking about. And I thought it was very strange. And what I realized is it was so hard for me to understand because I had all this physics knowledge that I've accumulated through the years. So I was trying to understand it through that lens. And I think if you don't have that and you go directly to Kafka from not knowing anything, in some ways it's a lot easier to wrap your head around how it's different from other technology and what it can do. So I think to help with adoption, you have to be patient and respectful with people and understand that, they've tried something before. I use this tool, I use this approach, it worked at scale, let me use it again. And to shift their thinking from everything at rest to everything at motion it's a journey. And, at Citigroup, we started the journey many years ago. I helped organize with Confluent's help a conference call. It was an hour presentation on what is Kafka, what is it good for? And we sent it out to the community, and over 900 people joined the session, from around the world. We followed that up with a hands-on training for people, about 50 people from all different teams. And we, got their hands dirty on a use case that was meaningful for their lives. So it was a financial use case. This is something that's relatable to what you're doing. And they were able to use Kafka in that session with Confluent team members around to be hands-on and to help them. So we kind of created, we did education in terms of reactive architecture, Kafka. We got people active using it. And we created this activity in the space. And then, over time, different teams are using at Kafka, and you're looking at your organization and you have a lot of Kafka in your space now. And then we began to think of things like Kafka as a service. So one of my colleagues, Lucian Hulada, is working on offering, users in our development community the ability to access Kafka for their applications, really as an internal service. And then as you're doing that, then you have to federate the data and have controls and proper things in place. So you could see how it started from, hey guys, there's this technology out there. Let's think about the right use cases and educate you, to how do you solve using this at scale with hundreds of users. So that's really exciting.
Sounds good. Yeah, that's lots of good advices there. Now, one last question. What's next? So what's next, in your plate for you and your team?
So I think, you touched upon it earlier, removing Zookeeper. If we're able to scale more elastically, in a cloud environment, Confluent Cloud is great. And I think that solves a public use case. At Citi, it's more, because of the nature of our data, it's more of a private cloud type of environment. So I'm keeping a close eye on project metamorphosis. So being able to set up cloud instances on our private VMs, private instances, and scale those linearly without Zookeeper as a gating factor. And going directly to something that's more cloud native is really something, that we're keeping a close eye on. I think also just basic things like multi-region, cluster failover support. We're looking forward to working closely with Confluent on that as we continue to expand.
That sounds good. Yeah, I think making Kafka more cloud native, making it more resilient across multiple regions, these are the things a lot of other companies are also looking for. All right, Leon, I think obviously, you had lots of experience with Kafka. So if you have to pick like one use case, one that's the most interesting and then also provides the biggest business impact, which one would you pick?
I think when you look at equities trading in a investment bank, you're dealing with data that has different timing. So you have real-time data, stock prices, things that are ticking. You have data that's pretty static, terms and conditions, things like that. And then you have data that's updating periodically, things like position updates. So if you can use a tool like Kafka to pull all that data together and combine it in ways that you display to end users, whether they be traders, salespeople, managers, and you provide them analytics across that data, it's extremely powerful. And so I think the systems we built using that have really transformed the way people think about, really what's possible.
That sounds great. Is there any like aha moment from like a business impact perspective?
Yeah, I think, we took a report that somebody was receiving the next day, and we were able to show them that updating in real time or near real time, on a website. And I think, and they were able to manipulate the data. And I think when they they understand that you can do this now and the technology's there and it's at scale, I think you see a light bulb go off in their heads and they say, well, what else can you do? Can I get data from here? Can you combine this? Can you show me this? And it really changes the nature of the conversation.
Yeah, that's great. Well, thank you a lot, Leon, for your time and your advice. It's a pleasure to have you here.
Thank you for having me. Have a great day.
Bye-bye.
All right, thank you for joining us for those opening keynotes. And I hope you got a sense of where Kafka's going in the future and the kind of impact it's having at large companies right now, and these really major use cases that a lot of us look to as an example of how we should move forward in our organizations. I hope you got some inspiration there. Now, the sessions are about to begin, so just a few quick tips. While you are attending the sessions, be sure to ask questions in the live Q&A window. Okay, in the platform, you can actually ask questions of the speaker. All the sessions are pre-recorded, but the speakers are there live monitoring that channel, responding to your questions during and after the session. So that's really a neat thing that the online platform gives you, even over above live Q&A in a live session. So check that out. Also, be sure to rate the sessions you attend. This data is very helpful, both for the speakers, so they can get feedback, and for us to know what kind of stuff really impacted you and which of the speakers you think really delivered for you. Now, these sessions are going to be available for replay on demand shortly after the session concludes. So if you miss one, there are sessions running in parallel, and if there's one you can't see, you can watch it later. So don't worry about that. Also, I said it before, but I'll say it again, tweet with Kafka Summit, the Kafka Summit hashtag, and take a picture and tweet it with the streaming selfie hashtag. Now, with that, time to get to the content. Enjoy the rest of the day.